Okay, here's our first video in section 3.9 on derivatives of general exponential and logarithmic functions. Let's think about, for a moment, all of the different functions that we know how to take the derivatives of. So we know how to take the derivatives of x to various powers from the power rule. Then we can add and subtract those functions. We can do polynomials. We can use the product rule. We can use the quotient rule. We know the derivative of e to the x. We know the derivative of trig functions. We know the derivative of composition of functions in the chain rule. So section 3.9 will wrap up. It will give us the last handful of functions that we need to know the derivatives of. And so the first function in this section is going to be the natural logarithm. So we're going to figure out what's the derivative of f of x is natural log of x. And how we're going to do this is we're going to do this using the methods of our previous section, section 3.8. That section is about implicit differentiation. So really, what we're going to say is, okay, y is equal to natural log of x. This is equivalent, y is equal to ln of x, is equivalent to saying e to the y is equal to x. And this is an expression, this is a equation that we can take the derivative with respect to x of both sides. So let's see what's going on here. So on the right is easier. The derivative with respect to x of x is 1. The left, the derivative with respect to x of e to the y, well, that's e to the y, but we also have to take the derivative of so by the chain rule, what's going on here, the derivative e to the y is e to the y times the derivative of the exponent with respect to x here. So our derivative is e to the y times dy dx. And rearranging this, we end up with dy dx is equal to 1 over e to the y. But revisiting our original expression, e to the y is equal to x. So what is our answer here? Dy dx is 1 over x. So if f of x is equal to natural log of x, f prime of x is 1 over x. So here is one more function to add to the list of functions that we know the derivative of. The derivative of natural log of x is 1 over x. Okay, so let's do some examples with this. By the way, it's worth me, before I go on to the next slide, it's worth to just put a little restriction on here. So the natural log of x, that's only defined for x is positive. So you can't take the natural log of 0, you can't take natural log of anything negative. So it's worth inserting that in here. Okay, so now let's use the fact that we know the derivative of natural log of x. Let's just do some quick examples with this. So, for example, the derivative of x times natural log of x. So this is going to be this looks like a product rule calculation here. So it's x times the derivative of log x, which is 1 over x, plus the derivative of x, which is 1, times leave this alone. So this simplifies x times 1 over x. That's just 1, so the derivative of x log x is 1 plus log x. Another example here would be the derivative with respect to x of natural log of x squared So it looks like we are using the power rule and the chain rule here. So what's this derivative? Our outside function is squaring. So the derivative of x is, the derivative of x squared is 2 to the x. But then we have to multiply by the derivative of what's in the inside. And so the derivative of natural log is what's in the inside, so that derivative is 1 over x. So that's a couple examples here. More examples, we can do kind of chain rule kind of thing here. So in general, the derivative with respect to x of natural log of f of x is, so the derivative of natural log of something is 1 over that thing, but then chain rule says we have to multiply by the derivative of what's inside, and so the derivative of what's inside is f prime of x. So this is a nice useful formula. So in general, the derivative with respect to x of log of f of x is the derivative of the inside function divided by that function itself. So we can do things like, let's do some examples here. If y is equal to natural log of x cubed plus 1, y prime is, so our denominator is going to be the inside function left alone, and the numerator is going to be the derivative of the inside function. So there's that example. We can also have one more example just to show off some stuff. If y is equal to natural log of square root of sine of x, so we're going to have a couple applications of the chain rule here. Y prime is, so once again, our denominator is going to be that inside function left alone. And then what's going on upstairs is going to be the derivative of, well, let's see here. We have to take the derivative of square root of sine x. So that would be 1/2 times sine of x to the minus 1/2 power. So, because sine of x to the square root of sine of x is 1/2 times sine of x to the 1/2 power. And then we have to multiply by the derivative of what's inside, which is cosine x. Why don't we take a moment just to rearrange this just a little bit to simplify it. So we're actually going to have, so sine of x to the minus 1/2 power, that's dividing by square root sine x. And so we can just say, oh look, combine those two factors into sine x. Here we'll be assuming that everything here is positive, so this all works out. This is a perfectly good way to do it. I'll observe that you could have done this in a different way if you had noticed that if y is equal to log of sine x to the 1/2 power, by log rules, we can pull that 1/2 down in front. So we're not taking derivative yet, we're just making our lives a little bit simpler. And so then when we are ready to take the derivative, the answer is just 1/2 times our denominator is sine x, the numerator is the derivative of sine x, which is cosine x. So that is doing a little bit of manipulation before we take the derivative, saves a few steps here. Okay, one last example in this section. I think it's worth noting here, just as a little fun example, The answer might be a little bit surprising, but we'll explain why it's the case. Let's think about y is equal to the natural log of 7x. So y prime, our derivative rules say the inside function is 7x, so we put 7x downstairs. And the upstairs, so upstairs here is the derivative of 7x. The derivative of 7x is 7. And so what happens, we get some cancellation, and the derivative is 1 over x. And so that might seem a little bit weird, that we said the derivative of natural log of x is 1 over x. And now we're saying the derivative of natural log of 7x is 1 over x. And so we're saying that these two functions have the same derivative, even though they look different. So it is something weird here. That's the thing you should be thinking about. Well, we can solve the mystery by asking ourselves, well, can we rewrite log of 7x in any way? So this is log of something times something. So our log rules tell us that we can rewrite this product to sum. This is natural log of 7 plus natural log of x. And now, if we take the derivative here, the derivative of natural log of 7, that's a constant, that's 0. And so we see that, yes, we get back to the same place using this new method. So so in general, if you take the derivative of natural log of any constant times x, you're just going to get 1 over x, because you could always rewrite things in this way. Okay, so I think that's what I want to say for this video. So as we discussed in class, from now on we're going to have some pre-class problems for you to write up and stick in Canvas. So here is your first pre-class problem. So don't find the derivative of x times natural log of x, all of that raised to the 1/5 power. So note here, this isn't natural log of x to the 1/5. So the inside function is natural log of x. Take all of that to the 1/5 power. So please solve this problem on a piece of paper. Write it up. Show me your work. Don't just show me your final answer, but show me some steps. And once you do all the problems from the section on one sheet of paper, you can upload it to Canvas.